Welcome you all. The last step in data science process is building the model. So data modeling actually involves three steps. First one is model and variable selection. Second one is model execution. And third one is model diagnostic and model comparison. So data modeling is actually a building a model or selecting a model. It is actually an iterative process. So the way in which we build our model depends on whether you go with the classic statistics or somewhat more recent machine learning school and the type of technique you want to use. So basically, the way in which we would like to build a model depends upon the data and the technique which we would like to apply to the data and how exactly we would like to obtain the result. So all these plays a major way or a major role in finding out the best model that suits our data. So generally, model consists of following main steps. So first step will be selection of a modeling technique and the variables to enter in the model. So as I've told you, which model is suitable for the data and what are the variables that are involved or what are the data that has to be fed as input to that model. So this one is the first one. Second one is the execution of the model. So running of that model, and third one is diagnosis and model comparison. So after the execution of the model, the results obtained has to be diagnosed and the same data has to be applied for say different other models, and the results of all the models are compared in order to find out the most suitable one. So model and variable selection. So what must the model be moved to a production environment, and if so, would it be easy to implement? So this will play a major impact in selecting the model, because we'll have to make an analysis whether the model we have selected should it be moved to the production environment. So if that is being done, will it be easy to implement the same? So these has to be analyzed. Second one is how difficult is the maintenance on the model. So which means how long will it remain relevant if it is left untouched. So second point also has to be analyzed. So is there any steps involved in the maintenance of the model? And if the model is left untouched, still the model which we have selected, will it be relevant for the data we have using? So all those has to be analyzed. So third one is, does the model need to be easy to explain? So third one is, for easier understanding of any model or the model which we are choosing, should it be easier to explain to all the person who doesn't know it? So all these are considered before we go for a model selection or a variable selection. So next we will be moving into Numpy to have to understand some of the basic concepts in Numpy. So NumPy arrays. So NumPy actually stands for numerical Python. So it is actually a general purpose array or a processing package. So this is used for all the high performance multi-dimensional array objects, and it provides the tools for working with these arrays. So this NumPy is a fundamental package for scientific computing with Python. So also it is a open source software freely available for anyone for use. So there are some features which NumPy are related with. So it is actually a powerful n-dimensional array object. So it has sophisticated functions. So it has or it holds the tools which are important for integrating them with C or CPP and Fortran codes. Also, it is useful for applying it to linear algebra, Fourier transform, and random number capability. So these are the important features of NumPy. So next comes a array. So what is an array? Array is actually used to store multiple values using a single identifier. So generally array contains a collection of data which are of same data type, and we refer to the each element in the array by means of using its position, or in other words we call it as index. So it is actually a zero based indexing. So what happens? These are the elements in the array. It, each and every value holds a index value which denotes its position. So NumPy array. So NumPy array, it is used to store numerical data or vectors or matrices. So this NumPy array actually consists of large set of built-in functions which are used for creating, manipulating and transforming the NumPy arrays. So NumPy is officially it is called as ND array or n dimensional array, but generally we call them as arrays. Creation of NumPy arrays. So if we want to create any NumPy arrays, first thing we need to do in Python is we have to import the NumPy as NP. So this is a statement which we'll have to introduce into the code in order to first proceed with any NumPy based operation. We'll have to import the NumPy library. So array creation, so conversion from Python structures like list, so using the NumPy function or using other library functions. So in upcoming slides, we are going to see how exactly these arrays can be created. So it can be done by using either NumPy functions. Inbuilt functions are available for creating these arrays. Also, other library functions are available, so which can be used for creating the arrays. So first way, using the NumPy function. So as I've told already, in order to use the functionality, we'll have to include the NumPy library or import the NumPy library. So this statement from here on, it will be present in each and every code. So after that, array is equal to NP. So NP dot array range of 20. So if we define like this, so this is used to create an array which holds 20 values, and it starts from 0 and ends after 20 values. So in this case, here you can see, so an array is created whose range starts from 0 and it holds 20 values. So it stops with 19. So if you print the output will exactly look like this. So this is how you create an one-dimensional array using a range function. So we have so many number of functions available for creating this array. So if you want to create a one-dimensional array, so np.array within the brackets you can give the values, and if you print and see, it will create an array. So this is creating a one-dimensional array. Suppose if we want to create a two-dimensional array, so you can use this functionality np.array. So within this you can see the first row has the values 1, 2 and 3. Second row has the values 4, 5, 6. So number of square brackets actually tells here the dimension. So since this is a two-dimension thing, we have two square brackets. So if we enclose it within a curly brackets like this, it will help to create a two-dimensional array. So if we print it, we can see we have an array with two rows, and the first row contains the values 1, 2, 3, and the second row contains the values 4, 5, 6. So as we have seen in the previous slide, by using a range also we can create an array and print it. So we have other two functions. One is using ones, another one is using zeros. By means of using these inbuilt functions also we can create arrays. So what happens, it if we give it like this, array dot underscore ones equal to np dot ones, this is used to create an array with 2 rows and 3 columns completely filled with 1 as the values. Similarly, array dot underscore zeros, if we give it like this, np dot zeros, it creates an array with 2 rows and 3 columns completely filled with zeros. So suppose if we want to create an array with random values, you can use this function np.random.random. So this will help to create a 2 by 2 matrix, and the matrix will be completely filled with the random values. So this is how we create arrays generally using the Numpy functions. Okay, so we'll see about this reshape function. So what happens here, in the first slide we have seen, right? So np dot a range of 20 is used to create a one-dimensional array with values 0 to 19. So suppose if you want to reshape it, see, since there will be 20 elements, we can reshape it to an array which holds 4 rows and 5 columns. The total number of elements should be 20. If you give some other values here, it may lead to error. So 4 rows, 5 columns. So what happens? This is 4 rows and 1, 2, 3, 4, 5. 5 columns are there. So the values are arranged in 4 rows and 5 columns. This is how you convert a one-dimensional array into any dimensional array by means of using this reshape function. So here some important things we need to notice. If we give a or r dot shape, so this will help to return the dimension of the array which we have created. So see here, in this case, ARR equal to NP dot array. This is the array we have created. So if we want to know the dimension by means of giving A or R dot shape, it will output as 2 rows and 3 columns. Similarly, if we want to know the dimension, you can give it as ARR dot NDIM. So this will return the dimension of the array. So this is a two-dimension array, as I have told you in the previous slide. So the output that will be displayed is actually 2. So if we want to know the data type, we can give it as D type. So this returns the data type of the array element. So the data type of these array elements is int 64. So int 64 will be printed. So ARR dot size. So if we want to know the number of elements in an array, then we can go for the function size. So in this matrix we have 6 number of elements, so output will be shown as 6. So this is how you create a one-dimensional array and arrive at or give different functions and get the values from that array. So as specified in previous slide, giving like this will create a 2-row 4-column matrix full of zeros and 3-row 6-column matrix full of ones. So np dot full we'll see in the upcoming slide. Okay, so see, suppose if we want to create an empty matrix holding no values, which is of one-dimensional form, if you give it like this np dot empty of 3, it creates a one-dimensional array which is completely empty, does not hold any values. Similarly, to a two-dimensional array, if you want to create 3 rows, 3 columns, you can give it like this. So, and three-dimensional array. If you want to create a three-dimensional array, okay, so what happens? 3 rows, 3 columns, 3 frames. So, all these are given like this. So, all the values are empty here. Similarly, zeros and ones we have seen for one-dimensional case and two-dimensional case. Now, we'll see for three-dimensional case. Similar to your empty function, if we give the number of rows, number of columns, and the number of frames. So what happens, that many number of frames are created and all the values will be filled with zeros in case of this and ones in case of this. So if we want to create a matrix like this, values in this diagonal, so what we can do, we can give np.I. So I actually refers to identity matrix. So an identity matrix will be created if you give this function. Okay, np.full. So I have told you, right? So what is this np.full? So this is within this brackets, you give a value, so that many number of times the value 2 has to be filled. So since this is one dimensional, so you will have three number of times the two values is placed. Similarly, if you look at here, for 3 rows and 3 columns, the value 2 has to be filled. So np.full. Similarly, 3 rows, 3 columns, 3 frames, the value 2 has to be filled. So, in that case, you give it like this. So, np.rand. See, in case of a one dimensional, you give it like this. If it is a two dimensional, you give it like this, 3, 3, and if you give it like this 3 comma 3 comma 3, 3 frames, 3 rows, 3 columns, random values will be filled. So if you give random, the values will not be exactly in binary like this, either zeros and ones. It can take different values, but whereas if you use this rand function, you will have only values returned, either zeros or ones. So all these things we have seen, empty I, okay, okay. Uh, so linspace. So this is a new thing which we have not seen. So what is actually this linspace is all about? So starting from 0 in 10, which are equally spaced, we require 4 number of values. So if you look at this thing, okay, so starting from 0 between 10, equally spaced 4 values are obtained. So if we want to do so, you can actually give this function and obtain this values. So some of the inbuilt numpy functions are given here. So empty like ones, zeros, fulls, all we have seen already. So as array. So this is used to convert the input into an array. So input, whatever form it is in, that doesn't matter. It can be converted to an array. Geom space. So geometrical space. So this particular function, it is used to convert the evenly spaced numbers on the log scale. So next, copy. So this copy function is used to copy, copy whatever values given in the object to another. So diag represents a diagonal array from buffer. Buffers as a one-dimensional array. From file means construct an arrays from the text or binary file. Bmat. It is used to build a matrix from a string or a sequence or an array. So this is used to interpret an input as an array. So Vander, this is used to generate a Vandermonde matrix, and try up U. Try upper. U stands for upper. So it is used to generate a upper triangle of an array. L means lower. Simply if you give try an array with ones at and below the given diagonal and 0 elsewhere will be generated. Diagonal flat, two-dimensional array with flattened input as a diagonal will be generated. From function, it is used to execute a function over each coordinate log space. So returns numbers which are equally spaced on the log scale and mesh grid. So return coordinate matrices from the coordinate vectors. So basic NumPy basic array operation. So these are the various functions So basic array operations that are available in the Numpy. So n dimension, which we have seen, size, d type, reshape, all we have already seen, in space, maximum, minimum, sum, square root. So these are the special functions which are used to perform some operations on the data in the array. So if we want to convert the array into a single line, then we go for Ravel. So we can perform some element wise operations in this particular Python. So how do we do so? You create two different arrays. Suppose if we want to add them, you can give print of array 1 plus array 2. So this will add both these arrays, and the added values will be printed as the output. Similarly, if we want to perform some mathematical operation, likewise multiplying it with the 2 or performing some other operation, that also can be done. So by doing this, so what do you give? Array 1, if you want to multiply it with 2, okay, so you define the array, give star 2, this will help to generate a matrix or an array which is exactly multiplied by 2 with all the elements in array 1. So indexing and slicing. So what happens in a given array? If we want to print some elements which are part of the array or any particular element in the array, then you can use this indexing and slicing operation. So suppose if you want to print the second element, if you do so, the second element will be printed. So similarly, if you want to print the elements starting from first index position to fourth index position, you can do so by giving it like this. So this is what you call as indexing and slicing. So reshaping function we have already seen. We generate an array, then we can reshape it in whatever way we want. Only one thing you have to keep in mind is the total number of elements in the array should match with the elements that has to be placed in the number of rows, comma number of columns after reshaping. So arrays in Numpy, so what all we have seen, checking the dimension of the array, so performing some basic operations in array, indexing the array, creating arrays, slicing arrays, going or dealing with higher dimensional arrays, and advanced method on arrays. So these are the various things that can be performed in an array. So this is all about finding out the dimensions in the array. So as I have told you, number of square brackets denotes the number of dimensions. So this is a 2 dimension. So this is 3 dimension. Now dealing with higher dimensional arrays. So by means of using Numpy, we can also create higher dimensional array. How do we exactly do so? You can give this keyword n dimension. So the dimension we are setting here as 10, which means these elements are placed in a 10 dimensional array. So if you print and see, so you can see here 10 number of square brackets are here. So this denotes that it is a 10 dimensional array. So all these brackets are nested one bracket within the other. So this is how you create a higher dimensional array using Numpy. So indexing and slicing. So we have already seen what is this. So if I want to print the particular element, then I can give the index value and I can print the particular element. So slicing means from the list of array available, if I want to print elements starting from a particular index value to and end in a particular index value, that also I can do so. So example is being given here. So you can clearly see here. So if this is actually the C array, if you give C 0, 0, so element this one will be printed. So if you give C 2, 0, 2, 0 will be printed. Okay, 2 comma 0 7. So if you want to print in C first row, okay, and from what is that, from the first column all the elements, then what happen, this is first row from first column, this is first column, from this if you give is to like this, which means from this element all the element till the end should be printed. So 9 and 5 are printed here. Similarly, from the first row and first column, okay, all the elements, see this is first row first column, what happens, 9 5 2 4 will be printed till the end. Similarly, if you give it as -1, indexing means what happens, see for this is 0 1 2, indexing go like this, -1 means anti-clockwise direction. So what happens, 1 6 8 9 will be printed here. So this is how indexing and slicing is done in a two-dimensional. Thank you.